Hi guys, Mr. Lawrence here, having about my 5th go to try and get this video made. Fingers crossed, I know this time it'll work. So I'm going to go through this fairly quickly and work through 3 examples of what you'll be doing tomorrow in class. Okay, first of all, we're looking at rational indices. So let's review what a rational number is. So a rational number is a number that can be made by dividing an integer by another integer. So for example, let's go to here. 1.5 we know is a rational number because it can be written as 3 over 2. Rational. What are some things that aren't rational numbers? Pi, square root of 2, lots of others. They're known as irrational numbers. But we've been working with indices this week. So a rational indice is an exponent that is a fraction. So the numerator indicates what power to raise it to. So if I've got a to the power of 3 over 2, the numerator, we're going to raise it to that amount. The denominator tells us to find the root of. Okay, the other thing to be careful of or to be aware of is that these can be written in different forms. All of these are ways that you may see rational indices written. They're all the same thing, they're just written in another way. Some of them we can use to our advantage while solving problems. For example, I'm going to be focusing on this for my first problem, which is 8 raised to 2 over 3. I can change the form on that very quickly. I'm going to change the form to 8 to raised to 1 over 3 and then all squared at the end. Sorry for my dodgy handwriting. I'm writing on an angle here. So I know 8 to the power of 3. This, as we were saying before, is the root. So root 3, or the cube root of 8, and then that's all squared. I'm going to do that a bit better if I can. Nope. All squared. So we all know the cube root of 8 is 2. All squared equals 4. The answer to 8 raised to the indice of 2 over 3 is 4. Here's the next one. This one poses a slightly different problem, but still nothing that we can't handle. 9 raised to negative a half. We need to remember our index laws here. So if we've got a negative index, we can put it under the line and make it positive. So I can rewrite this as 1, 9, now raised to a half. That makes it much easier because we've got rid of the negative. We know the denominator is the root. So let's now rewrite it. 1 over root 2, 9. We don't need to put the 2 there. We know the square root of 9 is 3. The answer is 1 over 3. All right, on to our third and final problem for this evening, before I try to get this uploaded to you. We've got a more complex problem here. We're going to take into account some of the things we learnt today, and we're going to rewrite this problem first. So let's rewrite it in a way that's helpful, because we have, if you look up here, we have things written in all different forms now, and we want to get them all into the same index form. So let's do that to start with. I've got 3 raised to a quarter. I'm happy with that. Okay, 6. I need to see straight away that I can divide 6 into 3 and 2. 3 times 2 is 6. Get them down to their primes. And I can also see that this is in the wrong form. We want everything in the same form. A square root is the same as the power of a half. So I'm going to use that now. I'm going to go 3 to the power of a half times 2 to the power of a half. So I've just broken this apart to 3 times 2. And then I'm left with this. how am I going to rewrite that one? So it's root 4. I know I can rewrite that as times 2 to the power of raised to the power of a quarter. That's all going to be over 16 to the power of 3/4. Now let's work on this bottom bit. This is in a form that we need to change if we're going to simplify this problem. So let's go to here. I'm going to concentrate on the bottom first. I'm going to break this apart like we did in the first problem. I'm going to go 16. I'm going to break that indice apart to a quarter, and then I'm going to cube it afterwards. Okay, let's write the rest back in. 3 to the quarter times 3 to the half. Actually, let's do 2 steps at once. I've got the same base here, both base 3, multiplying them together so I can add those indices. Let's do that now. Save ourselves 1 step. That's 3. A quarter plus a half is 3/4. All right, same base as here with the 2's. Half and a quarter, they're multiplying, so we can add those together. 2 to the raised to 3/4. Let's give ourselves a little bit of room here, and now let's work underneath the line again. Okay. I know that 16 root 4, remember the denominator tells us what root to use. 16 root 4 is 2. You can check that out if you like. 2 times 2 times 2 times 2 is 16. I'm going to raise that all to the power of 3. Up the top, I've got 3 still raised to 3/4 times 2 raised to 3/4. We're nearly there. Okay, we're going to simplify indices though. We need to combine all our bases where we can, and we want our answer to be in the positive, not the negative. So I've got raised to 3 there, raised to 3/4 there. Obviously the 3 down the bottom is of greater value, so I'm going to move this 2 underneath. Change the sign. Let's rewrite it. We're nearly there. 3 raised to 3/4 over 2 raised to the power of 3 times, now I've brought that 2 down, have to change the sign, negative 3/4. Just 1 or 2 more steps now to finish this off. I don't know what that k is floating around there for. This equals 3 to the 3/4 over. Now I can see 3 take 3/4 is going to be 2 1/4, but we're going to do it properly, okay? I want the same base on those indices, so I'm going to go 2. I know 3, I want it to be over 4. Excuse me. So I know it has to be 12, because 12 divided by 4 gives me that 3 that I need there. I'm going to times that by 2 to the negative 3/4. Now I've got the same base. I can combine those together and we can finish this problem. So the answer here will be 3 raised to the 3/4 over. So I've got 12 over 4, take 3 over 4, adding them together. So that 12 take 3 is 9, so it's going to be 2. And 9 over 4. And that is our answer. All right, I hope that makes sense and you can follow along. Tomorrow in class, if you've watched this video, followed it through, you'll be able to understand tomorrow with no problems at all.